Okay, so today's question is 238, product of array except for self. We are given an array of integers and we need to return an output array where the ith location of the output is the product of all the elements of the input array except for the ith input. So this is just equal to the product of all the elements of nums, and then divide that total product by this number, right? So for example, we have the input here 1, 2, 3, 4. The output is 24, 12, 8, and 6. We multiply everything together to get 24, and we then divide the product by each of the elements here to get divide 24 by 1 to get 1, divide 24 by 2 to get 12, divide 24 by 3 to get 8, divide 24 by 4 to get 6. So that's the quick and easy solutions to these problems. There are some other stuff following here. Constraint is that it's guaranteed the product of all the elements of any prefix or suffix of the array, including the whole array, fits in a 32-bit integer. So that 24, we multiply everything together, it's just this thing here. That's guaranteed to have no overflow. So that's the biggest number we could ever encounter with an input array. If that's not overflow, we don't get any kind of overflow problems, so we don't need to deal with such situation. The second thing is there's a node. We need to solve it without using division. So the one that I just described, even though it solves this problem correctly and very optimally, it doesn't satisfy this requirement. And as a follow-up, we should solve it with a constant space complexity. The constant space here does not count the output, so it's just the auxiliary data structures that we've been using to solve this should be constant. That just limits us to use a couple of variables, integer variables. And in this particular case, because we're dealing with product, that leaves us only, this stuff like multiply everything together, that kind of accumulator to accumulate products. So the way to solve this is to think about how we're gonna what's the output for each position actually consists of, right? So for 1 here, what we need to get is the output is 2 multiplied by 3 by 4. That's literally all the accumulated product for every element from its right, because it's the zeros in location element. For 2 here, the output is 3 multiplied by 4. That's all the elements accumulated product for all the elements from to its right, and also multiply that by 1 here. For this number 3 here, it's 4, all the elements accumulated product of elements from its right, and multiply that by 1 multiplied by 2. That's accumulated product for the elements from its left. For 4, there's no elements, but we could initializing the accumulator with 1. It's the same story here. And the accumulated product of elements from its left, it's 1 multiplied by 2 by 3. So that we would just reduce the problem of doing this accumulating product from the left, and the second pass to accumulate product from the right. And in the end, we just multiply the accumulated product where the location matches, to get the final output. So let me rearrange these things a little bit. I just call it the cum right and cum left. The output is just matching these locations to get 24, 12, 8, and 6. So that's pretty much the solutions to this. All we need is 2 accumulators, and we're doing 2 pass. So that's just a linear, that satisfies the time complexity as well. So let me code it up, the solution. So let's just grab the number of elements we have in the input array, and we are initializing the output to be, because we are getting products. Let's say that we have ones here as the initial value, and we have this two accumulator variables. So we can actually iterate over this, from left to right and right to left in the same time. And range n. Let's using some indicators here. Let's say that we're working with I equal 1 here. What we will do is to what we will do at this particular location is to multiply the output at this location by the accumulator from the left, and then for the negate I location, we will multiply the initial ones by the accumulated result from the right. So that's so that translates to into code as output at i's location multiplied by this, right? And we need to update the accumulator. So this will give us the output. So just to reiterate the process, we are accumulating this right accumulator from 1 to 4 to 3 multiplied by 4 to 2 multiplied by 3 by 4. Notice that we're initializing this by 1 here, and the order here is doing this update first, then doing this update. We update the output at the i's location before we update the accumulator. That's because at this particular location, we always lag 1. So initially this is 1. It's only at the second from the right we updated the accumulator by the the last element here. It's the same story with the left accumulator. At the first location it's the initial value, and at the second location it's the initial value multiplied by the first element. So the update of the accumulator always lag 1 before lags 1 compared with the updating of the output. So that's the solution. So it was working, and that's the question for today.